All
right. All right. All right. Is it that I'm doing it?
right. All right.
Oh, sure. Sorry about that. Ray, is it that I'm doing it correctly? I'm not even seeing your comment.
All right.
Hi, Taryn. Welcome. Share out the live touch. Well, I touch the screen. What do I do? Oh, I thought you were talking to me. All right. So I had to redo it, Taryn, because when I went on earlier, it never the screen wasn't showing, so I had to redo it. So it's just me and you and Ray. I'm gonna go back over something from yesterday. Hi, CNJ. Thank you for coming in. So as I said, Taryn, we're gonna be looking back on some fractions from yesterday. Um, we're gonna start back from addition, just doing one of each. So we're starting back from here. So again, it's a review, and then we're gonna go to something new today. All right. So again, if you're adding fractions with different denominators, again, we have to find the LCM. So that's the lowest common factor multiple between 2 and 3. And the lowest common multiple would be 6. So we create a divisor line to represent that. So between 2 and 3, our common multiple would be 6 because 2 can go into 6 and 3 can go also into 6. So now we're going to go to this part of it. 2 into 6. How many times we can get 2 from 6? And that is 3 times. So 3 times 1 is 3. We put back our addition sign, and then we're going to do this part. How many times we can get 3 from 6? And that is 2 times. And so we say 2 multiplied by 2, that gives us 4. Answer is 7/6. For the part where we want to know how to get this into a mixed fraction, you're going to be looking at, I'm just seeing you back, Raymond. So you're going to say how many times we can get 6 from 7. How many times we can get 6 from 7. And we know that we can get 6 from 7 one time. And how much is going to remain? So let us do some strokes here. 1, 2, 3, 4, 5, 6, 7. We can get 6 from 7 one time. That's one time. And we have 1 remaining, right? That one remainder, we're going to put that one remainder over our original denominator of 6. All right, and so that's why we got 1 and 1 over 6. So we draw our 7 things, or if you know what is it. So we say 6 into 7 goes 1 time, and we have a remainder of 1. We put that 1 over the denominator, which is the original denominator, which is 6. Any question? I'm not sure. You're not hearing me, Raymond? Okay. All right. And then if you're looking at a fraction with the same denominator, the same bottom number. So if you're looking at a fraction with the same denominator, so you have 1 over 3 plus, say, 2 over 3. Once you have the same denominator, you're going to just go ahead and add the numerator. Oh, really? I don't know. All right, so if you have the same denominator, you can go ahead and just add the numerator, and we're going to put it back over the same denominator. Once the denominators are the same, okay. All right, so once the denominators are the same, we just put it back, and then we're just going to add the numerators. So 1 plus 2 gives us 3. No, you can say 3. How many times you can get 3 into 3? We can get 3 into 3 one time, right? So they'll cancel out, and you'll get 1. So 3 over 3 is 1. 4 over 4 is 1. 6 over 6 is also 1. So once you have a number over itself, it is 1. You guys get that part of it? All right, so we're done with this. Multiplying. So we're multiplying 1 and 1 over 2 times, say, 3 over 4. Once you're multiplying a mixed fraction, it's easier to get this mixed fraction into a improper fraction. And how do we convert that? We always say we multiply the denominator by the whole number, and then we're going to add the numerator. So 2 times 1 is 2, plus 1 is 3, and we put that back over the same denominator of 2. Then you're going to put back what you have, 3 over 4. Now you can go ahead and multiply this. So you say 3 times 3 is 9, and 2 times 4 is 8. So with multiplication, you just multiply across, and that will give you your answer. How did you get 1/2? How did you get a half, Raymond? Yeah, 9 over 8. And what's 9 over 8 as a, we're trying to turn it back into a mixed fraction. What's 9 over 8 as a mixed fraction? Anybody? What's 9 over 8 as a mixed fraction? Yeah, good job. So it's going to be 1. So 8 into 9 goes one time and remained in 1 over 8. And so that's it. So the mixed fraction is getting your improper fraction to a mixed fraction is a problem. So let us look at that. All right, so supposing you had 7 over 5. How can we get 7 over 5 as a mixed fraction? So this is what we normally do. So we have 7 circles. 1, 2, 3, 4, 5, 6, 7. So we have 7 circles. We need to know how many times we can get 5 from 7. So we know it's going to be 1, 2, 3, 4, 5. So we get 5 from 7 one time. And how much is going to be how much we have remaining? We're going to have 1, 2 remaining. And so we put that 2 over our denominator, which is 5. And so 7 over 5 is the same thing as 1 and 2 over 5. Do you get that part of it? So the top number, you're going to divide it by the bottom number, your denominator. And so that's how we got 1. So 5 into 7, you get 5 from 7 one time. And we have 2 remaining. And so we put that 2 over our denominator of 5. Let us look at one more. So we have, so let us put, say 9 over 4. What's that as a mixed fraction? Let us try. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 circles, and we're going to see how many times we can get 4 from here. The light is kind of like shining on that. So we're going to see how many times we can get that. So we know we can get 9. We can get 4. 1, 2, 3, 4. So we get 4 one time. 1, 2, 3, 4. We get 4 two times. So we get 4 two times, right? So we get 2 times. We can get 4 from it. And how much is going to be remaining? 1. And so we put that 1 over 4. And so 9 over 4 is the same thing as 2 and 1/4. Congrats, Raymond. All right, so let Taryn try to get this one for me. I want it as a mixed fraction. So let's say 8 over 3. What is that as a mixed fraction? So giving you 30 seconds, 8 over 3 as a mixed fraction. All right, Taryn, come with an answer. What's your answer, Raymond? What did you get? All right. Okay, so both of you got the same answer. Let us check. So we can say 3 into 8, so we know it can't go 9 times. It can't go 3 times because 3 times 3 is 9. It can go 2 times because 3 times 2 is 8. It's 6, sorry. So 1, 2, 3, 4, 5, 6, 7, 8. We get one pair of 3, two pair of 3. So we get 2 pairs of 3 and we have 2 remaining and we put that back over our denominator. And so our answer is 2 and 2/3. Good job, Taryn, and good job, Raymond. So you guys are actually learning, right? Um, should I give you guys something a bit more? All right, let's give you guys one more. So let us say we had 12 upon 5. 12 upon 5, give me that as a mixed fraction. And then we're going to convert them back to, we're going to get back some others, and we're going to convert those back to an improper. So this is an improper fraction. An improper fraction is one which our numerator is larger, is bigger, is greater than our denominator. So this is an improper fraction. And these now, we have a whole number in front. Those are known as our mixed fractions. So you're going to turn this improper fraction into a mixed fraction for me, everybody. Ooh, somebody coming out really great today. All right, let us see. Raymond, what's your answer? Raymond, mine are cheating, you know. That looks our sound as if you're cheating. 2 and 2/5? Yes. So we can get 5 from 12 two times, and we have 2 remaining, and we put that back over our denominator, so 2 and 2/5. Great job. So I guess we're all good with that. All right, all right, supposedly now we have supposedly we have 1 and 2/3. What is that now as a improper fraction? We just looked at it. We want to turn this mixed fraction into an improper fraction. What is it? Okay, all right. So everybody got 5/3. Both of you got 5/3. So 3 times 1 is 3 plus 2, and that's 5/3. Great job. All right. So we look at turning mixed fraction into an improper fraction, and we looked at turning an improper fraction back to a mixed fraction. Now let us see if we can reduce fractions. Ooh, somebody's giving us explanation as to how she got the answer. Good job, Taryn. Woo! Somebody's doing good. All right. Great job, Taryn and Raymond. All right, so let us look at if we had. Thank you, Jesus' daughter, for coming in. Jesus' daughter, you forgot the time. All right, let us see. Sorry, I'm a bit stuffy. Let us see if we can reduce some fractions and how we would reduce them. All right, supposing you had, say, 18/24. I want this fraction to be reduced to its lowest term, right? I want the simplest form that we can reduce this fraction in, R2. So how do we do that? First, you look at the numerator and the denominator, and you're going to think of the lowest terms like 2, 3, 4, 5, and 6. And even greater, you're going to look which one would be easier to simplify this fraction. So when we look at it, we can say, oh, 2, if we can find a larger number than 2 that can go into 18 and 24. What about 4? 4 can't go into 18 without leaving a remainder, but it can go into 24, so that cannot work. 5 can't work. Yes, 3 can go into 18 and 24, but let us look a bit further. We looked at 6. So we look at 6. 6, yes. 7, no. 7 can't go into 18 without leaving a remainder, or 24 without leaving a remainder, so that's out. 8 can't go in, so we're going to work with the 6, right? So we're going to say at this point, how many times can we get 6 from 18? Good job, Jesus' daughter. Raymond went ahead and do the problem before. All right. All right. So we can get 6 from 18 how many times? We can get 6 from 18 3 times. And then we can say 6 into 24. How many times can we get 6 from 24? And that would be 4. And so indeed, JD, you are indeed correct. So we can't have a remainder, Raymond. So that's why we say we look for a number that can go into both numerator and denominator without leaving a remainder. And so 6 into 18 goes 3 times because 3, 6 is 18. And 6 can go into 24 4 times because what? 6 fours, 24. And so that's why our reduced fraction is now 3 over 4. Did you get it? Raymond, did you get it, Taryn? Okay, Tammy, no problem. I saw you putting your homework in the chat early on. All right, so let's go on to our next problem. We're going to try to reduce these fractions. So these are yours for everybody to do. Please tell me the number and your answers, all right? So don't just type the answers in the chat. So for number 1, you would say 1 is this, 2 is that, or 3 is that. So give me your answers for each of them. So for this one, I have 8 over 12. For this one, I have 20 over 36. And for the third one, I have 42 over 108. So I'm going to give everybody 1 minute. Raymond, I wish you could do that thing that you did yesterday, the 60 seconds thing. So 60 seconds. You're going to get 60 seconds to do all 3. So you're going to give me your answers for 1, 2, and 3. Your reduced fraction. So you're reducing. Reduce the following. So you're going to reduce the following, and then you're going to give me your answers in the chat. Again, please don't just type your answer. You have to say number 1 is this, number 2 is that, because I'm not going to know which one is which. All right. And then the answers are going to be coming in all at once. So do it that way so I can know what is what. JD, you're being unruly, ma'am. I have to take off my belt for you. I still want you to try tiring. So again, you're gonna look at each fraction and you're gonna find a number. You can start with two, you know. It's just gonna take you a longer time to do two for each of them. But you can start with two or three, depending on which fraction you're looking at. For example, number one, you can start with two. And then if it can be reduced further, you can go ahead again and reduce it again. So you can reduce it more than one time by two. All right. Try number one for me, Taryn. Let me see what you have. All right. I see JD. I see Raymond. Oh, again, guys, come on. We're reducing these fractions. Let us see what you guys get. Raymond, you look like your teeth. JD answer, sir. Hi, bro. Hi, Sikadan. Welcome. Thank you for coming in. Yes, guys, remember to like and yeah, that Mr. JD, I'm so like him a follow you. Cause look how long him take for give me that answer then. All right, are we ready? So let us get on with it. All right, so for number one, 8 upon 12. All right, I'm a math teacher, so I'm gonna know the answers. So I'm gonna ask you guys to tell me what number can we use to divide into 8 and 12 without leaving a remainder? Which number can we use for 8 and 12 without leaving the remainder? Without leaving a remainder. Find a number. Which number it is? We can use 2, yes. Is there a greater number though? Is there a greater number that we can use, guys? Raymond, what did you get? All right, JD, thank you. So yes, let us use 4. So we can say 4 into 8 goes 2 times, right? And 4 into 12 goes 3 times. So the answer for number 1, yes, Taryn, is 2 upon 3. All right? But if you wanted to use 2, Taryn, let us look at 2. We can use 2 because we could say 2 into 8 goes 4 times and 2 into 12 goes 6 times. So our new fraction would be 4 over 6. But this also can be reduced by 2 again. So we could say 2 into 4 goes 2 times and 2 into 6 goes 3 times. And see, we still get back 2 over 3. All right, so you could use 2 as well as 4. But if you use the smallest number, you're going to take a little while to break it down to the lowest form. All right, for number 2, 20 upon 36. What's the number that you guys use? Which factor did you guys use to reduce 20 and 36? All right, Raymond said he used 2. JD, what did you use? You used 4. All right. So let us look at let us start with Ray and then we're going to look at JD. But indeed, 4 into 36 goes how much time, JD? 4 what? Give us 36. It's above 8. So we can say 20 over 36. We're going to use a factor of 4, the number 4, because that is indeed the highest number. So 4 into 20, how many times we can get 4 from 20? We can get 4 from 25 times. And we can get 4 from 36 9 times. So we can get 5, that's the answer, 5 over 9. This cannot be reduced any further, because there's no number that can go into 5 and 9 without leaving a remainder. Or we can use 2. So let us use 2. 2 into 20 goes 10, and into 36 goes what? 18. And then we can say again, 2 into 10 goes 5, and 2 into 18 goes 9. And so we ended up back again with 5 over 9. So your answer for this one is 5 divided by 9. Everybody seen that? Is there any question? Any question, guys? All right, going on to the third one. 42 over 108. What's your highest common factor for 42 and 108? What's the highest common factor, guys? Which number you use? 42 and 108. All right, we're going to use 2 for 42 and 108 first, since nobody's answering. And let us see if we can find a larger number. All right, JD says 7. Let us look at that. 7 into 42 goes what? 7 into 42 goes 6 times. And 7 into 108. Let us see how many times can we get 7 over into 108. And 7 into 108. How did you get 7, JD? 108 divided by 7, you're going to get a decimal. So recheck that one. Recheck that one. Raymond, give me a number that can go into 42 and 108 without leaving a remainder. Is there another number than 2? All right, let us try. Give me another number, guys. I'm not going to give you the answer or tell you which number. Yes, 2 can go into 42 and 108, but there's another number. There's a larger number. All right. All right, Raymond say 8. So 42, yes, 42 can be divided by 8 without leaving a remainder. No? So we're going to try 6. Because when you look at 42, 2 and 6, so you would say, I'll use 6. So 42 divided by 6 and 108 divided by 6. So 42 divided by 6 goes what? 7 times? Right? And 108 divided by 6 goes 18 times. And so that's how we get the answer, JD, that you got. So you're going to use 6. So 6 is that number. 6 into 42 goes 7 times, and 6 into 108 goes 18 times. So your reduced fraction would be 7 upon 18. All right, so yes, the answer would be 7 upon 18. Do you guys have any question for me? Yeah, so 6 is the number, JD. So you use 6. So 6 into 42 goes 7, and 6 into 108 goes 18. And so reduce is 7 over 18. Do you guys have any questions? Okay, Raymond, be quiet. All right, so let us look at another one. Raymond? All right, let us look at one more, and then, I said 1 hour, so I have like 21 minutes remaining. All right, so we can do decimals as well, so let us do that. Raymond, you want to join in? So as a decimal, so let us look at a decimal, a number, a fraction. So we have, say, 2 upon 10, and we want this as a decimal. It simply means you're going to divide by 10, right? That's what this is saying. So 2 upon 10 is the same thing as 2 divided by 10. Once you're dividing by 10, your means you're going to move one place to your left. And so our point is going to be here, our decimal point is going to be right there. And so our answer is going to be 0.2. So 2 divided by 10, or 2 upon 10, or as a decimal, is 0.2. Supposing we had 3 upon 100. It's the same thing as 3 divided by, it's the same thing as 3 divided by 100. And it simply means you're going to move your decimal point from your right, two places. So the amount of zeros that is there, that's the amount of places that you're going to move your decimal point. And so we're going to move from the right to the left 2 places. 1, 2. So our decimal point is going to be here. So you have to put a placeholder in this. Right, you're going to put a decimal place right there because it has to hold that place, right? And so your answer for here is going to be 0.03. Sorry, 0.03. And so that's your answer for that one. All right. 3 upon 1,000. What's your answer, Raymond? 3 upon 1,000. What is 3 over 1,000 as a decimal? All right. Yes, Raymond. Yes, Taryn. So that as a decimal is 0.003 because you move 3 places to your left. Um, we're gonna change it up. Supposingly though we're gonna become a little bit more complicated. Supposingly we have say 2 upon 3. What is that as a decimal? Without a calculator. You don't have a calculator in the exam. So you want 2 upon 3 as a decimal. The first things I'm going to teach you this one, and then I'm going to give you guys one to try. It simply means you're going to take the denominator and you're going to put it on the outside of your quotient of your. Okay, no problem, JD. So it's going to be 3 in your divisor and you're going to put 2 in your underneath your line there. And we're going to be saying 3 into 2. So we're going to try to divide it this way. So 3, how many times we can get 3 from 2? Can we get 3 from 2? Raymond, can we get 3 from 2? No. So we can't get it from 2. So we have to put a 0. We have to add a 0. And then we're going to put a decimal point. Right? So once we can get 3 from 2, we have our 3 from whatever number. You put a decimal point, you had a 0. And now you're going to say 3 into 20. How many times we can get 3 from 20? 6 times, right? Because 3, 6 is what? 18. So 18 from 20 is 2. So again, you're going to say 3 into 2. You can't. You add a 0. 3 into 26. And you're going to realize it's always going to be 2, 2, 2. So it's going to be 6 going on indefinitely, right? And so 2 upon 3 as a decimal is 0.667. And it's continuous, so you can put a line on top because it's continuous, right? And so that's how we got it. If we want to round it off to 2 decimal places, it would be 0.67. Why not 0.6 or 0.66? Because when you look to your right, the number is greater than 5. And once the number is greater than 5, you have to add 1 to the 6, right? Or whatever number is here. Again, once the number to your right is greater than 5, you add 1. And so to 2 decimal place, it would be 0.67. What if it was 1 decimal place I wanted it? What would it be? So you look to your right again. If it's greater than 5, you add 1. So what is this to 1 decimal place? Yes, Taryn. Thank you. So your answer to 1 decimal place, 1 dp, 1 decimal place is 0.7. 2 decimal place is going to be 0.67. 3 decimal place, it will be 0.667. So you guys understand how we got the decimal places? Do you guys understand how we turn our fraction 2 over 3 as a decimal? Do you guys want me to do one more, or you guys want one to try? All right, you want to try? All right, here it is. So I want you guys to do 4 upon 5. So 4 upon 5 as a decimal. I'm going to keep this one here for you guys to see. So 4 upon, oh, you want me to do one more? Sure. All right, I'm going to keep that 4 upon 5 for you guys. Raymond, you can try that one. We're going to do one more. So we have like 13 minutes remaining. All right, so let's do one more. So we're going to look at 1 upon 3. What's that as a decimal? So we are going to do the same thing. You're going to put your denominator outside your divisor, and then you're going to put the 1 within. And so we're going to say 3 into 1, you can't. So you put a point and you add a 0. Then you say 3 into 10, it goes 3 times because 3 times 3 is 9, right? 3 times 3 is 9. And so 9 from 10 is 1. And so again, we realize that we're going to have 3 going on and on forever, right? Because that's then again, you're going to end up getting 10 and 10 and 10. So 1 over 3 as a decimal is 0.33. So 1 upon 3 as a decimal is 0.33. Is that clearer for you guys? Is that helping? All right, Raymond, I saw your answer. Taryn, you want to try the problem? Let us see what you get. Let us do one more while you guys are trying 4 over 5. So the one that I gave you is 4 upon 5. I'm going to do one more. So let us use a 3 upon 5. Let us see that one. As a decimal, you put your 5 on the outside, you put your 3 inside. So it says 5 into 3, you can't. You put a point and you add a 0. 5 into 30 goes 6 times. 6, 5 is 30. And so 30 from 30 is 0. And so those are gone. So your answer for 3 over 5 as a decimal would be 0.6. All right, that's your answer for 3 over 5. Oh, gotcha. Understand. All right, so everybody see how we got 3 over 5 as a decimal? So again, we put our denominator on the outside of our divisors, and then we put the 3 on the inside. 5 into 3, you can't. You put a point, you add a 0. And so we say 5 into 30 goes 6 times. And so we say 5, 6 is 30. 30 from 30 is 0. And so 3 over 5 as a decimal now is going to be what? 0.6. Yeah, she's a busy girl, Ray. And you know what kids are, they need attention. All right. So Raymond, let us look at yours. So 4 upon 5. So let us see if we can get that as a 4 over 5 as a decimal. I know you will. All right, so 4.5 as a decimal, you're going to put your 5 on the outside, as I said before, your 4 on the inside. So 5 into 4, you can't. So you put a point or a decimal point and you add a 0. And now you say 5 into 40. How many times you can get 5 from 40? So we can go up and we say 5 ones 5, and you go on and see what's the closest number you can get to 40. 5 into 40, Ray? So we want to do it the long way. 5 ones 5, 5 twos 10, 5 3 15. Thank you, Raymond. 5 8 is 40. All right, 5 8 40. So we get 0 0. So our answer for this one is 0.8. So 0.8 as a decimal. So 4 upon 5 as a decimal is 0.8. So good job, Ray. You got that one correct. All right, what was the homework yesterday? Anybody remember the homework from yesterday? We're gonna do one more. So let us say 2 upon 5. 2 upon 5. Yeah, you're good. 2 upon 5 as a decimal. 2 upon 5 as a decimal. Giving you guys 30 seconds. 2 upon 5 as a decimal. Somebody's moving really quick. All right, so Ray says 0.4. Let us see if he's correct. All right, so we're going to say 5. 5 into 2, you can't. So you put a point and you add a 0. 5 into 20 goes 4 times. 4 fives, 20. And so that's 0, 0. So 2 upon 5 as a decimal is 0.4. Go, Raymond. Good job, Ray. All right, let us see how it goes with this one. Say 2 upon 8. 2 upon 8 as a decimal. What is that? 2 divided by 8 as a decimal. Oh, thank you, Raymond. Anybody? All right, so let us work on that one. 8 as a decimal. So again, 8 is on the outside, 2 is on the inside. I don't know what happened. Yeah, I don't know what happened. I'm trying to get it back. I don't know what I did, if I did something. I think that the cam is out. The cam is not working. It's going in and out. I don't know why. I don't know what. Mm, I don't know what. And I think you guys are seeing me. Mm. It's supposed to project. I don't know. Me do that rare. I understand what I'm going. Me do it, man. Me come up, me do me close it. I plug it out and plug it in back, and it's still I do the same thing. Tap on camera, then select back facing camera. Alright, tap on camera. Camera. I have a Spanish golden 703 right? Oh no. Camera. Shit. Oh Lord Jesus, I gotta be a fat, you know. Camera. Let me touch Hey, Taryn, me feel bad. Me don't know what else to do. I forgot buy one. Miss can't get one for about $126. I'm gonna try buy one. Again, this I probably do it time. Yeah, but it now do that now. Yeah, it start. I plug it out and plug it in several times and it's still a. I don't know neither. Sorry, when I come in then, I go try. Remember that? No, me can't bother. Me dead in. All right. I go try if me can. Taryn still there with me. Um. All right. Let me see. Let me see one last time if me can get it. It's still I go back to front camera. Front camera. I want me turn it a while ago. Me press my camera right. And me close this. And it's still I show the front camera. Mm. Oh, there we go. Hopefully no come off again. Go show me that. It come on back. Me end up do back again when me do it. When me did do all this time, it finally work. It look like a camera. My projector need for battery, yeah, man. Mm. Yeah, hear me? Yeah. All right, Taryn, thank you. All right. Yes, my could just finish up the problem and give two and me get to cut it out. Hello, me need this. Me now I'm mother that show this video, yeah, Papa. Me tell back here. You can come back in. Yeah.
They got my sweet bread.
Hi, darling. Ooh, let me just keep the arsenal. All right, so let us get this fraction into a decimal. All right. All right, so let us try. So we can go ahead and say 8 into 2. You can't. So you put a point, I put a decimal point and you add a 0. And then you say 8 into 20. How many times we can get 8 from 20? We can get 8 from 20 how many times? I'm really sorry about that. Oh my God. 2 times, right? So, yes, so 2 eighths, what? 2 eighths is 16. And so we have 16. 16 from 20 goes what? 4 times? 4, you get 16 from 20, remaining 4. My projector, I'm scared to touch this thing. And then you say 8 into 4, you can't, you add a 0. So 8 into 40, how many times you can get 8 from 40? How many times you can get 8 from 40? Okay, 5. Because 5 8 is 40, so yes, 5. And so 5 8 is 40, and so we ended up with 0 0. So our decimal for 2 over 8 is 0.25. So that's your answer for the decimal. One more decimal. What's the decimal for, say, 4 upon 7? 4 upon 7. What's the decimal for that one? Remember, no calculator. 4 divided by 7. Good job, Ray. Anybody with the answer yet? 30 more seconds. All right, Dolly, come in with hers. Still waiting on the others. Ray, Taryn, what's 4 over 7 as a decimal? All right, let us go to this one quickly. And then we're gonna give some for homework. All right, so 5, 4.7. And so we know we're gonna have the 7 on the outside and 4 on the inside. 7 into 4 you can't. You put a point and a 0. Or 7, and then you say 7 into 40. How many times you can get 7 from 40? 5 times. 5 7's 35. And we put our 5. And so 7 into 5 you can't. You put a 0. 7 into 50. So 50 divided by 7. How many times you can get 7 from 50? And that is 7 times. And 7 7's 49. And so we have 1. 7 into 1 you can't. You had a 0. You place 7 into 10 goes 1 time. And so we're going to stop right there. And so the decimal for this is going to be 0.57. So that's the decimal, 0.57. That's rounded off to 2 decimal places. If you're going to round this off to 1 decimal place, it would be 0. What? We learned this early on. What is this as a decimal? To 1 decimal place. 0.57 to 1 decimal place is what?
What?
0.57 to 1 decimal place is what, guys? Good job, Taryn. Woo! Yes, 0.6. So the answer for 4 over 7 as a decimal would be 0.6 or 0.57. Well tried, Dolly and Raymond. All right, you guys want one to try and then you get your homework? One more to try? So let's use 7 upon 8. What is that as a decimal? Giving you guys 40 seconds. Okay. Yes, Dolly. So next time you focus on that, all right? So we always have to try to round off. So once it's 5 or more, we try to round it off to the nearest number. So if it is 1 decimal place to the nearest 1 decimal place. All right, what's the answer for this one? What's the decimal for this one? 7 upon 8. What is 7 upon 8 as a decimal? All right, so Raymond has his answer. Still waiting on the others. Dolly, what did you get? Taryn, what did you get? Remember, you're going to use this number, the denominator, Josh, and try to put it into the numerator and see what we are going to get as a decimal. All right, let us do it together again. So 8, 7 upon 8. So we're going to put the 8 on the outside, 7 on the inside. We're going to say 8 into 7. You can't. You put a decimal point. You add a 0. Then you're going to say now 8 into 70. How many times we can get 8 from 70? We can get 8 from 70 8 times. 8 is 64. Right? And so 64 from 70 goes 6 times. You're going to have 6 remaining. So 64 from 76. And then 8 into 6, you can't. So you put a 0. And then you're going to say now 60 divided by 8, or how many times can we get 8 from 60? And you can get 8 from 67 times. And 7, 8 is, 8, 7, sorry, is, or 7, 8 is 56. And that remaining 4, 656 from 56 from 60 is 4. Can't, you add a 0. 8 into 40 goes 5 times. 8 5 is 40. And so 0, 0, right? And so your decimal would be 0.875. If we're rounding this off to 2 decimal place, it would be what? 0.88. And if you're rounding this off to 1 decimal place, it would be what? 0.9, right? Everybody remember that? So 3 decimal places would be 0.875. As 2 decimal place, it would be 0.88, and 1 decimal place, it would be 0.9. Any question? Do you guys get this, or you want me to go over another one? Yes, you are correct, Raymond. I will not sure so you get your answer. What about you, Taryn? You want me to go over, or you're good? Dolly, do you want me to redo one more, or you guys are good at this? Yeah, he did. All right. So these are your homework questions, and I remember the ones from yesterday. I'm gonna go through those. I can. You want me to go over one more? All right. So let's go over one more. So 1/2. 1/2 as a decimal is gonna be 2 into 10 into 1. 2 into 1 you can't. You add a point. You place a 0. 2 into 10 goes 5 times. And 2 5s 10. And so that's 0, 0. So 1/2 as a decimal is 0.5. Right? Any question? All right. So let me go ahead. What if I have 20 over 7? All right, so we can look at that one. 20 over 7. So if you had 20 upon 7, you would have to put the 7 on the outside, of course, and 20 on the inside. 7 into 20, or 7 to 2 you can't, so but there's a 0 already, so you're just going to say 7 into 20. 7 into 20 goes 2 times, because 2 7s 14, and we're going to have 6 remaining. 7 into 6 you can't, so you're going to add a 0. So it's going to be, so you're going to have a 0, but when you're having that 0 now, you're going to put a decimal point. So once you add a 0 for the very first time, you're going to put a decimal point, right? And so you say 7 into 60. So it's going to be 60 divided by 7, and that will be 8 times. And 8 sevens, 56. And so 4 is going to remain. 7 into 4, you can't, you add a 0. 7 into 40. So 40 divided by 7 is 5 times. 7 5 is 35. And so you'll realize that the list goes on and on. So I'm going to bring it down to 3 decimal points, and then I'm going to round it off, all right? So we have here, so 5 is going to remain. 7 into 5, I can't, you add a 0. 7 into 50. So 50 divided by 7, and that's 7 times. And so we're going to stop right there. So this now as a decimal to 2 decimal places, it would be 2.86. To 1 decimal place, it would be 2.9. And so that's 1 decimal place, 2 decimal place, and 3 decimal place. So your answer for that one would be 2.857. If you are doing 2 decimal places, Raymond, it would be 2.86. So 2.85 would be incorrect if you're doing an exam or a test. All right. All right. All right. So I am going to conclude this. And I guess that's it for this part of it. Taryn, did you see the thing that I placed on Instagram? Arisa, could you take the puppy outside, please? And give him some water.
All right, mommy.
Alrighty. Go, Jess. Go drink some water. All right, so guys, we'll see you guys on tomorrow. If there's any question or there's a topic that you guys want me to go over, you can always put it in the comment section and I'll be happy to go over it with you guys. All right. Have a blessed evening, people.